Hey there everyone, Basante here, and today I will be talking about the von Neumann architecture and the system architecture. Now, the earliest computing machines had fixed program in it, and one of them were the table calculators, which could take input, process, then output as a result. So, yeah. The problem was you couldn't change the program because it was a fixed program, and if you did want to change it, you would have to change the hardware. And it was all because it was a fixed program. Now a stored program is a computer that has changeable program. In 1945, the mathematician and the physicist John von Neumann described the first design for modern computers that had stored program. This way of designing modern computers that had stored programs came known as the von Neumann architecture. Now all that being said, let's get started with the system architecture. The von Neumann architecture has key characteristics. The central processing unit, which consists of the following components: arithmetic logic unit, which performs calculations and logical decisions. It has a control unit, which sends the signals to the control, how data moves around the CPU. It has a cache, which provides fast access to frequently used instructions and data. It has a program counter, which holds the address of the next instruction in the memory. It has a memory address register, which holds the address of where data is to be fetched or stored. It has a memory data register, which holds the data fetched from or to be written to the memory. It has an accumulator, which holds the results of calculations. Von Neumann architecture fetches instructions from the memory, decodes, then executes them. Now the programs are made up of sequences of instructions stored in the main memory outside the cup. They fetched one by one to the registers for processing. Now this is the memory, and each instruction is stored in a location in the memory. Each location has an address, therefore the processor can fetch an instruction stored in the memory, address 1 for example. Computers are complex machines capable of fetching and executing billions of times a second using a sequence inside the CPU. The address in the memory of where the next instruction can be found is stored in the program counter. So first instruction is at address 1. Therefore, the value in the program counter would be 1. This is then passed to the memory address register. Then the instruction is fetched down into the MDR, which would say load address 5. Now the program counter would now have to point to. Now a copy of what was loaded into the CPU is in the cache. So if it's needed again, we don't have to go back to the main memory in order to load it again. Now the control unit is going to decode this instruction load 5 and fetch a value from the address 5 in the memory. So the MAR is going to change its value 5, and we're going to go and going to fetch what's in the address 5, which is 23, down into the MDR. So the MDR would now contain 23, and we'll put a copy into the cache. Then our value 23 can now be passed into the accumulator. So that's one instruction that has been fetched and executed. Now the program counter is pointing to the address of the next instruction in the memory. In this case 2. So 2 is going to get passed into the memory address register and out to the memory, and we can fetch what is in the address 2 down into the MDR. So this is add what is in the address 6, or copy is stored in the cache, and we need to increment our program counter to, so that becomes 3. So now we need to add what is in address 6. The control unit is then going to pass address 6 to the memory address register. Go and fetch what is in address 6, which is number 12, and that's going to come down into our MDR, into our cache. So we're going to add 12 to 23. So the arithmetic logic unit performs the calculation, so we're going to get 35, and the result is stored in the accumulator. So the program counter has the value 3, so that gets passed into the memory address register and then goes out to the memory invoice in address 3. Store in address 6 gets passed down into the memory data register, so store 6 will keep a copy in the cache and will increment our program counter to 4. So control unit is going to look at this instruction stored in address 6. It's going to change the memory address register to 6, and then the value in the accumulator 35 is gonna go back to the memory to data register and then out to the memory address 6. So 12 is no go, and there gets overwritten by the value 35. We know we would also keep a copy in the cache. PC contains the address of the next instruction 4, so that gets passed into the MAR out to the memory, and we find our instruction that comes down into the MDR, and we need to increment our program counter. Now the CPU is going to decode the instruction and realize that the end of the program, and that's it. It's the end of the program.